Okay, let's look at this idea of equations, solving them. Essentially, all you're really doing is making the pronumeral that you're trying to find the subject of the formula. That's essentially what you're doing. Okay, so, well, in fact, I was going to say the very first basic type of equation you would have seen was something like this, but actually no. Even before you saw ones like this, you saw equations back in primary school, infant school, except they did something, their pronumeral, they didn't use an x. What did they use instead? Yeah, a box or a triangle or a circle. But essentially you were solving equations. You know, what goes in the box? X plus 3 equals 6. The way I think about these things is I think about moving terms. I know a lot of people will say, oh, well, look, if I want to get rid of the 3, I'll just subtract 3 from both sides, which is true. That's what you do. But the way I think about it is I look at that and say, I want to get x by itself. I want to get that 3, I want to move it to the other side. And I know that when I move it through that sign, or the equal sign, I've got to change the sign of the number as well. So essentially, I don't write that down, but essentially I'm saying, hey, I'm moving that 3 over. I now know I've got x equals 6 minus 3. So I get x equals 3. Something like this. 5z equals 45. I want to get the z by itself. Well, it's a factor, so I undo the factor. How do you undo that? Factorising is dividing. So divide by 5, 45 on 5. Well, of course, that's 9. Now this one here, I've got a choice. I could expand the whole thing out first, or I could divide by 4 first. Which do I do? I expand it out. Okay, so I've expanded out, got 4a minus 20. I want to get a by itself, so I'll move that 20 over the other side. Now I'll divide by the factor, and I get 9. That's the basic idea behind equations. Then we said, hey, let's make them look a little bit harder. There's z's on both sides? Oh no, not a problem. I'm going to move the 2 over to the right hand side. I'm going to move the z to the left hand side. There it is, 2z equals negative 11. Now the advantage of thinking of division as fractions is I don't have to do anything with this one, because 11 over 2. Brilliant, that's an answer. Some people are paranoid and they will rewrite that as 5.5. But why? Why? 11 on 2. It's a good number. In fact, I don't know if you're aware of this or not, but that is, of course, where the division symbol comes from. Think of a division symbol. What is it? It's a fraction. You got a vinculum, something on the top, a numerator, something on the bottom, the denominator. That is the division symbol. That's where it comes from. Okay, oh no! Pronumerals in the bottom of the fraction? What do we do? Well, fractions, yuck. Let's get rid of them. So you multiply everything by that common denominator, in this case, 7y. Then we saw ones like this. There's a little beautiful trick we found, and that is, well, when I've got a fraction equaling a fraction, all I've got to do is multiply along the diagonals I could create there. 3 times x plus 3 equals 5 times 2x minus 6. Move our terms round, and we get our answer. Okay. Quick little recap on equations there.